All right. Okay. Yeah. So in this session, we're gonna discuss about Azure SQL Database, Serverless, and Hyperscale. When we first started Philippine Data Day, when we were planning, I was planning to let you deliver a session regarding SQL Server and when you can use what type of SQL Server. But when I was developing the content, it's too much of a content to be delivered on an hour. At the very best, you can deliver it in 3 hours because there's so many ways you can deploy SQL Server right now. So I've decided to focus on these two because I love talking about these two because they're on the opposite end of the spectrum. So we're gonna learn about serverless and hyperscale. Uh, Before we continue, we'd like to take our sponsors, Microsoft and DB Watch. So as I shared to you guys earlier, this event is brought to you by Philippine Data Platform Forum. It's the database SQL Server database group for Philippines. If you would like to join, if you'd like to learn more about data platform and other technologies related to data, you can join the group. Just a word of caution: we're a bit picky on who we add, so make sure you answer all the questions on when you join the group, because there's a few questions that we try to screen our members. Yeah, so our agenda for today is to understand what Azure SQL Database Serverless is, identify the workload and the database workload and scenarios wherein you can use serverless, as well as Hyperscale, understand its unique advantages, and we are going to discuss the architecture of Hyperscale, how it can be done on the cloud, how can it do all the performance upgrade that it has on the cloud compared to on-prem. Before we dig deeper into those two deployment options, let's discuss. I'm going to show you first what type of deployments are available for you on the cloud. Just a quick question to everyone: do you guys have database loads on Azure right now? Are you using SQL Server, Azure SQL Database on your company, or Azure VM? Yeah, of course, I cannot see you guys. Anyway, so
Not yet, not yet.
not yet. So this will give you a bit of an overview. The first deployment option is deploying SQL Server in a virtual machine, which is your infrastructure as a service deployment option for SQL Server in Azure. What you have is an Azure VM, similar to your virtual machines on-prem, but this one is fully managed by Azure. The advantage is you have access to the OS. That means if you have any custom applications, any custom permissions that you require on the machine where SQL Server is running, then this option is for you. If you also need to install a specific version of SQL Server, then Azure VM is the deployment option that you should be looking at. So, like I said, it has an expansive SQL and OS version support, because you can choose whatever version of OS and SQL Server you're going to install. The downside is, since it's IaaS, you are responsible for everything from the OS up. So patching, keeping your OS up to date, keeping your SQL Server up to date is your responsibility. The security, the HADR, the high availability and disaster recovery scenarios for your servers, you need to configure on your own. For example, if you need availability groups, you need to configure it on your own. You need to set it up. You need a DBA to set it up and configure it for you. Similar to your backups. So here you need to plan for your disaster recovery scenario. So you need to manage your own backups. Aside from that, if you need to have multiple sites where you can fail over, you need to set it up on your own. This type of deployment option is best for applications that require OS level access, like I mentioned before. So this is for your legacy applications that you want to move to the cloud without changing a lot of things on the application itself. The next one is a managed instance. So here is a more of a compromise between an Azure database and a full SQL server. What they noticed when they started moving people to the cloud is most companies they will always go to Azure VM instead of going to an Azure SQL database because they have a lot of on-prem. They are using a lot of on-prem features of SQL Server, like SQL Server Agent for your jobs. Maybe you're using CLR, your service broker, or for example, you're using a lot of link servers on your application. So those are not available when you're using Azure SQL Database. But for managed instance, it's a full instance of SQL Server. So most of the server level features are available for you. You can also mimic the separation in the VPN. For example, for most on-prem database server, we always put it on a separate segment of our network, which is not available to the DMZ or it's not internet facing. So for managed instance, you can do that. So so you can mimic whatever you have in whatever you have on-prem. So it's more compatible with SQL Server on-prem. It will give you an easier path for migration. Uh, there's another thing coming for managed instance. Now, it's still in preview. It was supposed to go in public preview earlier this year, but I think it got pushed. It got pushed back. But yeah, there's gonna be an instance pool. The problem with managed instance, it's too big for some of the smaller SQL servers you have on-prem. For example, if you only need one CPU or if you only need two vCPU or half a CPU, you cannot do that with a single instance. So what Azure did is to create an instance pool wherein you pay for a certain amount of CPU and then multiple instances can share that resources. So it's a more cost efficient way of migrating to the cloud. So like I said, managed instance is more appropriate for most lift and shift migrations to the cloud because it has a wider set of SQL Server features that you have. Then on top of that, you have all the platform because it's a platform as a service. You have all the benefits of a PaaS offering. That means you don't need to manage your backups. The backups are automatically managed for you by Azure. The HA, the DR, it's already there. It's already redundant. So once you launch a managed instance, it's already certified to have 4 nines of availability. That's 99.99% available. The read replica is already there. You just need to enable it if you want to do something similar to AG. So all the intelligent features of PaaS is available for you when you use managed instance. You have query tuning, the performance monitoring. So it's the best compromise between having a full SQL server and the benefits of a service offering. And then what we have is a single database. This is the Azure SQL Database. So for Azure SQL Database, it's more for multi-tenant applications. For example, you have an application that creates multiple databases for each client. For example, if you have a client A, it has its own database for its application. If you're that kind of software shop, this is the best thing for you because the resources and the billing for each database is isolated from one another. So you can track the performance of the database. It's dedicated for that database itself. The billing for that database is dedicated. So it's easier to bill your client and to figure out how much you really are spending per database. And it's also allows you to scale your scale your databases a lot quicker than you can do on-prem. That is actually the major benefit of putting your databases in the cloud. It's allowing you to scale your storage, scale your compute a lot faster than you can do on-prem. Uh, SQL database also has an elastic pool configuration wherein you have a single elastic pool and then you can put multiple databases on the pool itself so that they can share the resources. This is for example, you have an OLTP database that is active for the whole day, but during the night, there's no one using it on the business. And then you have another database, which is an OLAP data warehouse database, for example, that most of its jobs are running during the night. So if you're gonna pay for a single database, you're gonna pay for example, 4 CPUs for the whole day for each of them, even though it's not being used during the off-peak periods. So what you can do is you can put them together to have a more cost-efficient way of using your resources that you're already paying for. So most of the databases, most of the new applications that you're creating, if it's in the cloud, it's highly recommended to use Azure SQL Database as your backend because, like I said, you benefit from a lot of things. You don't need to manage your backups. You don't need all the administrative overhead are on Azure. It's not on you. If you don't have a DBA on your company, it's better if you deploy on a SQL on a PaaS offering instead of on-prem because you don't need to manage your high availability, your HADR. It's gonna be configured for you, and all the security features available for the application is there. And the thing with managed instance and Azure SQL Database, it will always be on the latest version of SQL Server, and you don't have to do anything because it's updated and patched for you by Azure. So all the new features of Azure SQL of SQL Server will always be available for you to use when you're on a managed instance or an Azure SQL database. So for Azure SQL database, there are quite a few options on how we call it tier. There's two types of compute tier. A compute tier where it's provisioned, and then the one that we're going to discuss today, which is serverless. So what is SQL database serverless? SQL database serverless is the on-demand flexible scaling up of your database. It's automatic. It auto scales for you. It pauses and resumes your database load when it's not in use. It's the most cost-effective way of having a database in the cloud because compared to the provision compute, you pay by the second. And then on top of that, you still benefit from all the features of a PaaS. So all the intelligent tuning, intelligent monitoring for you. It's done. It's part of the offering. It's highly available once you deploy it. So it's fully managed and intelligent database service. Uh, this type of deployment option is best for unpredictable and intermittent workloads. So what are the reasons why we have serverless and why would you go for serverless? The hardest thing for a new application, for example, for any new applications, if you ask a developer how much CPU will this use, how much storage will this application use, how much does it need, it's very hard to get an accurate estimate on how much resources your database will use, especially if it's a new application that you have never used before. So what always happens is you either over provision, you pay for more resources and then you're not using it, or you under provision wherein your application keeps on getting hit by timeouts and performance issues. So serverless addresses that. It helps you. What serverless does is you can deploy it first on database serverless. Serverless allows you to scale. It automatically scales your application depending on the load. So if it needs more CPU, it will give it more CPU. If it's using less CPU, it will then release those resources. So once you get the uh, accurate usage of your application, that's the time that you can, for example, if you really need a provisioned resource, then that's the time that you can move to a provision compute. But aside from new applications, there are a number of line of business applications that are um, more appropriate to use, where it's more appropriate to use serverless instead of provision compute. For example, we all have for example, a performance review application for your business. You really usually use it unless it's the performance review session. Or for example, if you have an expense application for your business, you don't really use it unless it's time to log all your expenses for the month. So for the whole month, for the first 3 weeks, for example, it's not being used, and then on the last week, a lot of heavy usage for that application. So if you're paying for the provision compute for the whole month, then you're wasting a lot of resources when it's not in use. Same with, for example, an e-commerce application wherein you launch a new sale, for example, or a new marketing campaign. So during those sale promotions and marketing campaign period, then your usage and your resource usage and requirements will shoot up. If you're using provision compute, you might not be able to adapt to that load, to that sudden increase of load, compared to how serverless can handle it. Serverless can automatically scale your compute and your storage. So, but I'm not saying that you cannot do that on a provision compute. You can do that on a provision compute, but you need to script it out. You need to uh, find the event or the schedule wherein you are supposed to scale your application, your database. But for serverless, you don't need to do that. It's managed for you. It's also applicable for dev and test environment, wherein you're not really using your dev environment every day. Or for example, your dev and test environment is usually unused during the off hours, right? You only do development during business hours. No one's using it when during the night. So if you're using provision compute, you're paying for the whole day. So that's where serverless is applicable for sporadic, unpredictable usage of application, and for applications that have long period of inactivity. Are you guys following so far?
Yes.
All right, cool. So let's compare, so that we can taste it a little better. Let's compare it to how it's happening on provision compute. So for a provision compute, if you see here, uh, oops, if you see here, this is an example of a provision compute. So he provisioned his database to have 4 cores of 4 CPUs. So if you do that, you're always gonna pay for 4 CPUs by the hour. So even if your usage, if you can see here, his usage is below 4 CPU, he's still paying 4 CPU because that's the provisioned CPU for him. And once it hits 4 CPU, what usually happens is you get an alert that uh, you're consuming your resources already. So what happens when you need more than 4 CPU? Usually you get timeouts, or your performance gets throttled. So you have 2 problems. You have unused compute resources, the blue lines. You can see the blue lines going up and down. Those are unused compute resources that you are paying for. And once you hit your max, you hit your CPU, it won't scale for you. So uh, we'll compare that to what serverless can do for you. On serverless, we have a few additional settings that we set. We set a max CPU, a minimum CPU, and the pause threshold, the auto pause delay for your database. So what happens is you set the minimum CPU. For example, here one. The lowest that you can go is I think half a CPU. So what happens is that's the minimum that you get billed for when there's activity on your database, when your database is online. So as you can see from the graph, it starts with one. And then as your load creeps up, for example, there's more transaction, more queries coming in. Uh, what happens is as the demand for the workload increases, the number of CPUs also increases. So your resources also goes up. The resources available for you until you hit your max CPU that you set. Uh, but unlike the provision compute, you are only paying for the CPU that you are using. For example, here he's only already beyond one CPU, but for example, if he's already as he goes up, he only pays for the CPU per second. So during the point in time that you're using just two CPU, you're just paying for two CPUs for that second. Once it goes up, then that's when you go and pay for more. So until you reach your max CPU. And then what happens when your resources, when your transaction starts to calm down and go down, the usage starts to go down. The system will also start releasing the CPU that you're using, and you're only billed for the CPUs that that your application is consuming, until you again reach the minimum CPU, and then uh, there the auto pause delay kicks in. For example, there's no more transaction for the graph. For example, the when it reach 22 around 23 11 p.m. nobody's using it anymore. There's no more transaction coming in, no more logins coming in. So it will start the count. Once it reach an hour, because the auto pause delay, the lowest you can set the pause is for an hour. So once it reach an hour, it will turn off your database. It will pause your database. And during the pause period, you're not charged for any compute. So unlike provision compute wherein the charge is continuous, here your database can be paused when it's really not in use, and you're not charged with the compute. You only pay for the storage for your database. And then once a new login comes in, it will bring your database back online and give you the minimum CPU that you configured and start uh, as your database workload creeps up again, then it will start getting more resources as the demand grows. So you have two places where you have where you have cost savings for serverless when your database is paused, and the fact that you're only paying for the CPUs that you are using. So this is how it's happening in the background. So for serverless, you have a management plane, for example, that a management plane that or that administers your database. So it starts with your database online, and then once it monitors the activity. If there's no login, like I said, if there's no session, no transaction coming in for the period of your auto pause delay, for example, for an hour, it will start to pause your database. When it starts to pause your database, what it will do is it will take a tail log backup of your database and detach the database files, and that will terminate your billing for the compute. There was a question when I delivered this session on in Wellington. They asked how long does it take to pause the database? According to the documentation, it takes around 10 minutes to to pause the database because uh, as you can see, the activity, it will take a tail log backup and then detach the database files. The document, the SLA is around 10 minutes, but it's actually a lot shorter than that. And once during the pause period, like I said, there's no billing for the compute, and then a new login is received for your database, or a new connection is spawned connecting to your database. This is this is the drawback for serverless. The first login will always fail because that's the event that will tell the management plane that this database is required again. So the first login will initiate the resume tasks for the database. So what it will do is it will it will attach the database files to the instance again and start the SQL instance. So it will start billing you with the compute once it completes that task, and then your database is back online. So uh, the catch here for the login receive, the first login will time out. Uh, Someone also asked, how long does it take to resume your database? The SLA is around 1 minute, but yeah, it's usually a lot faster than that. But as the documented time is around 1 minute. Uh, Regarding the login receive, some people always ask, then it's a problem, right? Because your first connection will time out. Your first connection will fail. For cloud applications, the best practice is to have a connection retry. Whenever you use an Azure SQL database, or no matter what cloud provider you're using, if it's RDS or GCP or Azure SQL, it's always recommended to have a connection retry logic on your database connection because of the network latency and all the because some of your traffic might go to the internet, right? So the best practice is to have a connection retry. So it shouldn't be an issue as itself for itself. The first login failure. So let's. Are there any questions before I go to the demo?
Yes. None so far.
I have a
Question.
Sir, my question is regarding the auto pause. Can
Hmm.
we know the egress time before it takes the procedure of pausing?
Yeah, that's the delay. So, for example, an hour. So for an hour, if there's no connection, then after the hour, then it will start pausing sequence.
So that would be the minimum.
Yeah,
6 minutes.
yeah, that's the minimum. Right now, they're trying to get it down, but currently the minimum delay that you can have is an hour.
Okay. Thank you.
Okay, so I recorded this demo last time at Wellington, so I'm just gonna reuse the same. So here is the way you can. This is how you create a hyperscale a serverless database. If you notice if you notice the command, it's the same command with all the Azure SQL database. You see the service objective, it's general purpose. S is for the serverless, and then Gen 5 is the hardware version, and then 4 CPUs. So if you're gonna deploy, for example, provision compute, you're just gonna delete the S. It's gonna be GP underscore Gen 5 underscore Gen 4. The generation, the version of your hardware will determine how many CPUs you can, the max CPUs you can provision. And then the last number is the number of CPUs that you allocated for this server. So this is an example of a serverless that I had. It's currently paused because I stopped using it around, I think, 7:15, 7:36, 6:45, 6:45. Yes, 6. Yeah, there you go. 7:36 p.m. So by 7. Yeah, I stopped using it at 7:46. So it paused. If you can see here at the far right side, there's no billing. Now we're gonna try to reconnect to it. Like I said earlier, the first connection will pause. Will time out. If you notice here below, if you scroll down later on, when we try to connect, then it will. That's the time that it will start the resume operation. If you scroll down below, it will say the database is resuming. So it usually takes around a minute, but since I'm using SSMS, it will use the connection timeout for SSMS. So right now it's what in the background what's happening is the management plane will now reattach the database and then bring up the instance. So here you can see the first connection timed out. But once I connect again, if you see here, it's no longer resuming, it's already online. So once I connect again, I'll be able to connect to the database itself. You can notice it doesn't need to be on a separate logical server. You can mix and you can put a serverless compute and a serverless database and a compute database, a provision compute database on the same logical server. So we're just gonna let it have some time to generate because we need to generate code so we can see the usage. Let's issue some transaction. So let me open a query. Then I'm gonna I'm just want to generate some activity on the database. Let me do a random select on the objects. And so that we can see the load, I'm gonna do it multiple times. So I'm gonna do it more than a million times. So let's do another session so that we can see the load or so that we can see the load on the database. So what I'm doing right now is just generating random transactions to the database so that we can see the compute usage for the serverless database. So while that's running, it will start to generate if we refresh. This is, by the way, the management portal for Azure, if you're not familiar with it. So if you go to there you go. You can see the graph starting to come in. The first graph is the usage. The graph below is the billing. So as you can see, there are transactions coming in because CPU is being used. Let's let it get some more data so that the graph looks better. While it's running, let us take a look at the how you can create one from the portal itself. So these are all my Azure SQL. One thing that you've noticed if you've been using the portal before, they currently change it. They now have an Azure SQL section where you can create whatever you want. The SQL database, the SQL managed instance, the SQL virtual machines. Makes it easier to find and create one for SQL Server. So I'm going to create a new SQL database. The name and then the server. Like I said, for the server, it doesn't need to be a separate logical server because it's just a logical database. So once we configure, you can see here, there's two compute here, provisioned and serverless. So for serverless, uh, there's your max vCores that you can allocate and the minimum vCores. As you can see, for Gen 5, it's up to 16 vCores to 48 gig of memory. If you notice here, one CPU is equal to 3 gig of memory of RAM. So that's how it's allocated. So as you go up, you get more RAM in 3 gig increments. So this is the auto pause delay. So right now it doesn't allow it to pause in minutes. The least you can do is an hour. And then of course you can see below the database, the data max size for the database. So once you click apply, then you can proceed and create your database. So now it's creating. We go back here. Let's just see. Um, well, it's deploy. Let's just see how can we. How about if you want to change a provision compute into a serverless and vice versa. So for serverless and and provision compute, uh, you can change the compute here very easily. You can change it through the Azure CLI, PowerShell, or through a T-SQL. Here, I'm going to show you how you can change it on the Azure Portal. You just go to configure and then just change the provision. So for provision compute, you change it to serverless, and then that's it. For serverless and provision, you can go back and forth without uh, and still be able to use your backups because it's the same scenario. The only difference is the compute here. Your because for like I mentioned earlier, for Azure SQL database, your database is managed for you, right? So it keeps the backup history of your database. Just the compute, only the compute here will change. And the same thing for serverless solutions, the same thing. The change should be that shouldn't impact your application. It happens on the back end. So yeah, so that's Azure serverless for you. So just a quick recap: serverless versus provision. For database usage pattern, you use serverless for intermittent, unpredictable workloads. For applications that have long inactive periods. Provision compute is for applications that have a regular usage pattern already that requires high average compute utilization over a time period, or multiple databases using elastic pools. You cannot put serverless in an elastic pool. So performance management effort, since you don't need to create it, since serverless auto scales on its own, it's lower maintenance than provision. Like I said, compute scaling is automatic. For provision, you have to manage it on your own. Compute responsiveness, since your database can be paused, there might be times wherein it's the compute is lower when it starts compared to provision wherein you always have the numbers the number of CPU that you require. For serverless, you start with your minimum. And then for billing granularity, it's per second compared to per hour, so it's a lot cheaper. But a warning here, it is billed per second, but it's billed higher than provision compute because of all the other features. So if you are gonna use your database regularly, for example, it's gonna be in use most of the time, then serverless compute will cost more than a provision compute. Like uh, like we said, it's for workload scenarios that are intermittent and unpredictable. Uh, yeah, so that's the summary of Azure Database Serverless for you. Any question? No?
And so far. And so far.
Yeah, am I running over time?
Just on time.
Okay, so Azure SQL Database Hyperscale uh, is on the opposite end. This is for very large databases. So the challenges for large databases is how long it takes to do any kind of activity related to your storage. Any size of data operation takes longer. For the attendees right now, what's the biggest database that you had? Just shout out the size. Anyone here has managed terabytes of database?
Almost 1 tera.
4 tera. As long as you reach the tera, the large database size, any activity will take longer. Backups takes longer. Restore takes longer. Adding storage takes longer. It's gonna be painful if you need to change your compute because you need to move that data with you. Usually, for example, for a 4 terabyte database on an on-prem, it will take days for a backup. 12 hours, 4 to 12 hours of uh, activity for just for the backup, and it affects the performance of your database. So Hyperscale addresses all that because Hyperscale allows you to grow your application limitless. So there's no more limit to how big your database can be. It can grow up to 100 terabyte. Right now, for an Azure SQL database, the maximum is 4 terabyte. For Hyperscale, the theoretical limit is 100 terabytes, but if you have more, uh, Azure would likely be able to provide more storage. And then it allows you to have performance operations constant time. The backup time and the recovery time for a database is the same whether it's 4 terabyte or 100 terabyte. It's the same. And the compute and storage you can scale rapidly independently of each other. So Hyperscale is a complete re-architecture of SQL Server in the cloud. So it's a new scalable architecture, storage architecture for SQL. It's built entirely for the cloud, and it's fully compatible with existing SQL Server. So uh, your T-SQL will still work. Everything. It's an Azure SQL database offering. Uh, so it's compatible with all your existing tools. It takes out the headaches of for very large database operations. And like I said, you can scale your compute and storage limitless. So just some uh, some stuff regarding hyperscale. It's the same with Azure SQL Database. It has multiple levels of redundancy, so it's always. But once you deploy it, it's 4 nines of availability. There's no single point of failure in any point of the architecture, which we'll talk about later. And then it's highly scalable. It scales independent. You can scale your storage and compute independently, and it's scales quickly. There's no size of data operation, no matter if it's a 50 terabyte or a 4 terabyte, the performance is the same. So there's low latency and high throughput for large database compared to what's available on-prem, and backups are a lot faster. Like I said, you're gonna be surprised if you are an existing database administrator and you know how long it takes for the backup. You'll be surprised. Uh, let's talk about the architecture itself. There's 4 parts for the well, 5 parts of the for the architecture: the compute engine, the log service, the page server, the remote data storage, and the Azure storage. So we're gonna discuss each one very quickly. Uh, the primary, what you have is a primary server. It's a SQL server. It has you configure how many cores you require, and then the memory for this SQL server has directly attached SSD. It's proportional to the number of cores that you will deploy. So it has a non-covering RBPX. If you are familiar with it, resilient buffer pool extension is an extension of your memory. So it's similar to your buffer cache. So most of your recent transactions and your recent data will be on the RBPX. So if it's on the cache, the data access is less than 0.5 milliseconds. So it's a lot faster. So it will service the read-write workloads for your application. And you also have a readable secondary. It's the same as your primary. The memory is also directly attached SSD. It's a local SSD, so it's the same point, less than 0.5 milliseconds for any data on the cache. You can configure up to 4 readable secondaries, and you can redirect your read-only workloads to your readable secondary, similar to what you can do with uh, an AG or a mirror. So it's also the hot failover target for your primary. Then this is your storage for hyperscale. For hyperscale, you have a number of page server. Each page server is responsible for 128 gig of your data. So for the page server, it's a remote SSD. It's a premium remote storage. The data access is around 2.5 milliseconds. But this one is a fully covering cache. That means the entire 128 gig that it is responsible for of your data, it's on the cache. So it's all in memory. So on checkpoint, the page server will push your data down to a database to a data file. This is the reason why Hyperscale can do their backups very fast, and how they can assure the similar performance no matter how big your data is. The database file for the actual database file is saved on an Azure standard storage, separate from your page server. So all the backups are happening on the snapshot or the standard storage, not on the SSD. That's how it doesn't impact your performance. And then Hyperscale also re-architected how transaction log works. The transaction log for Hyperscale is called log service. It has a few components. It has a log landing zone wherein all your new transaction will go to, and then it will cache it on the service. It's called a log service. It's gonna put it on the cache on its memory, and then there's a long-term storage for the log that is never truncated. All your committed transaction will be on the long-term log storage. So it's very resilient. The new transactions are hardened on the landing zone, not on the long storage. So the long-term storage log. So it's a lot quicker, and it caches your transaction on the service. So it doesn't wait for it to deliver your transaction to all the secondaries and to all the page servers. It's asynchronous. That's why it can serve it faster. So this is the entire architecture. You have the primary, and then you have secondary servers, and then the log service is the one that orchestrates all the information regarding the transaction between the components. And then you have a number of page servers that is responsible for their segment of data. Just a quick sample on how a transaction is happening. So you have a write transaction, it goes to your primary. Uh, Once it hits your primary, it will go to the log landing zone. Once it reaches the log landing zone, the transaction is already committed. So after that, the log service will put it on its buffer cache, and it will asynchronously deliver the transaction to the secondary and the page servers. Once it delivers it to all of them, then it will push it to the long-term storage log, where your whole transaction log is kept. So if you do a read transaction, your read transaction will hit your primary. If there's no application intent specified, then it will hit your primary. If the data is in the buffer pool, in the RBPX, it can retrieve it within 0.5 seconds, and that's the end of the journey. If, for example, you have if it's not on the cache, then it will go to your page servers, but it won't hit your uh, actual data files. It will hit the RBPX on the page server where the data is. So it's still less than 2 milliseconds. So if you specify your read-only intent, then your transaction will go to your secondary, and the same thing will happen. If it's in the cache, it will service it from there. If it's not, then it will hit your page server and get it from there. So if you compare, if you notice the difference in the performance is in the RBPX on the whether your RBPX is an attached SSD or a remote storage. So if you compare it to the other offerings, GP is using an Azure storage, so it's gonna be a remote storage. So every call for GP is around 2 milliseconds. The business critical service tier it has attached SSDs, so it will always be zero point 0.5 milliseconds. And then hyperscale sits in between of those two, wherein you have zero point 0.5 milliseconds and you have for your calls that are in memory on the primary, and 2 milliseconds for those that are on the page servers. Any questions so far before I play the demo? So I just want to show you guys how you can provision a hyperscale. It's the same thing as Azure SQL Database. You can use PowerShell. You can use T-SQL here. Here I use T-SQL to create the database, or you can use an Azure CLI. So while it's creating that database, like similar to the other database, the last digit is the number of CPUs you want to allocate. So if you do it from the Azure Portal, it's the same path. You put a database name, and then when you go to the compute and storage, here is where the different here is where it differs from Azure SQL Database. For a hyperscale operation, it's a one-way trip because of the architecture is different. It has a warning here that once you change a database to a hyperscale, it cannot go back to any other type of database. So it asks you to accept that risk. So that means if you have backups of your existing Azure SQL database, after you move it to Hyperscale, those backups cannot be used anymore. It won't be usable on Hyperscale, and Hyperscale backups will not be usable on an Azure SQL database. So looking at the deployment options, looking at the options again, if you go back, so similar to serverless, it can sit on the same logical server as any Azure SQL database. Here you can see the max CPUs for Gen 4 is 24. If you change that to a Gen 5, you can have up to 80, I think 80 CPUs, and you can have up to 4 replicas. The default is 1. Uh, Something to note here, there's no storage configuration for for a hyperscale because it allows you to scale your database. It automatically scales your database storage. You don't need to provision anything, and you can grow up to whatever you want. For an Azure SQL database, the maximum you can go is 4 terabytes. In terms of moving your database between general purpose and hyperscale, like I mentioned earlier, any general purpose database, you can change it into hyperscale but you cannot open it back. And for example, here I have a Gen purpose here, and we can convert it into hyperscale by just changing the compute here. You can also see here all the benefits that you have for having for using an Azure SQL database. You can see the geo restore, all the advanced security and auditing that you have that you don't need to configure. When you're on-prem, you need a DBA to figure out all those things to set it up. So here you can see you can change a provision GP into a hyperscale, the single. So this one is a hyperscale. You can see you cannot change it back to a general purpose or business critical. You cannot change it back to an Azure SQL database. But you can quickly change your CPUs, the number of CPUs. This is what I wanted to show you guys. For restoring a database on-prem, it will take you 4 hours to restore maybe a 500 gig database. For here, I have a 50 terabyte database in Hyperscale. The clock on the left side is continuous, but I'm gonna fast forward it. I mean the video I will fast forward, but the time itself is continuous. So we're gonna restore the 50 terabyte into a new one. For point of comparison, a 4 terabyte database may take around 4 to 12 hours to back up and a lot longer to restore. So here you can see it's already started. You can see here Hyperscale. Yeah, so now it's restoring the database. The reason why it can do this is, like I said earlier, it's using snapshots. So what happens in the background is it will look for the snapshot of your storage, of the Azure data storage, and align it the snapshots for this page for whatever page server you have. It will look for it, and then it will provision it in parallel. So, for example, you have a 10 terabyte database. You likely have around 58 or how many 120 page servers. So what happens is all those restore happens uh, parallel. The same with your log service. It will look for the snapshot of your transaction log. Remember, your transaction log is never truncated. So you have two benefits there. If you have any high volume insert or high volume deletes, any high volume transaction, what usually happen on-prem is you run out of transaction log if you don't back up quickly. For a hyperscale, it's not an issue because it's never truncated. So for restore, it's also the same thing. It will just look for the snapshot of the storage and it will provision a new server for it. If you look here, the database is already available. It's just applying the snapshot. So it completed it in under 8 minutes. It's a 50 terabyte database. If you have been restoring database before, you're gonna be surprised with that speed because it usually takes 12 hours. And this one is a 54 terabyte, 50 terabyte database. Awesome, right? Anyway, yeah. So that is what hyperscale is. It's a highly scalable and reliable uh, option for you on the cloud that is highly scalable and allows you to grow your database limitless. So it has a constant backup time and restore for any size of the database. So if you expect your database to grow beyond 4 terabyte, this should be the option for you. So Just to close, I'm Pio Balistoy. I'm a lead Microsoft Data Platform consultant for PTN Services. Like I said, I am the community leader for Singapore SQL Pass, and I also help with Philippine Data Platform Forum. If you have any questions, you can reach me through that email and through any of my blogs or any of the social media. Uh, Questions?
What is PUism?
Sorry?
What is PUism?
PUism? Yeah, that's just my thoughts. Everything PU does.
Okay, thank you.
So don't forget to do your session evaluation. That's gonna be your entry for the raffle later on. You can scan that and then it will direct you to a form the survey.
Ayan.
Any other questions?
Ay, okay, wait lang ah.
Natatakpan pala.
Ayan, okay. Pasensya na. Ayan. Kailangan nyo yan. Kasi pag walang ganyan, walang chance to win the
Tingin ko na ako. Ano na? Once na hindi na maglalagay na. Lalagay pa.
Ayun, your name.
Okay, thank you.
Ano lang, nasa hulihan lang.
Actually, yeah, later on I'm also gonna show you something cool later on when we do the raffle. Any questions while you guys are doing the survey?
So yan, walang halong daya yung raffle na yan kasi sa Singapore ito-draw yung raffle. Although, ewan, baka Singaporean yung DTI representative natin, ano?
No, actually, it's gonna be cool. I'm gonna do it's an extra session actually because I did everything power ups. So later on, see how it happens.
Mag-lightning talk ka ng power ups.
Sumaside ng power ups.
Sumaside ng power ups.
Any questions while you guys are filling up? Anything about SQL Server that you have, or anything about the session?
Ang tawag dito. Maliwanag pa sa sikat ng araw ang discussion at naintindihan nila. Grasp nila yung hyperscale. Ang galing ano? SQL server siya pero serverless. Ba't di pa nila ginawang SQL serverless?
Ito lang yung
Miss chance.
server nila sa cloud. Hyperscale, di ba? So, gagawa ko ng database. Kailangan pa bang may sarili ng table na kayo? Set ako ng gagawa ko ng create table. Gagawa database tapos table na. Tapos yung table na yun, lalaman mo yun. Kung pamangalanan mo.
Yep.
Diyan din mismo pa kung gagawa ng table.
Yes. Pio, quick question. Yung hyperscale is manageable through SSMS, right?
Yeah, it's completely the same. The way you access your on-prem database is the same way you access any of your Azure SQL database. The commands are the same. The T-SQL commands are the same. It's the same engine. It's the same database engine. So any of your existing tools should work. Any of your existing scripts should work. So the way, sorry?
So pwedeng diretso na akong mag-create ng table dyan mismo sa Hyperscale.
Yes.
Yep. It's the same thing.
A question. How about na the migration from on-prem to hyperscale? May ano ba yun? Direct migration na tool for that?
There's
Migration.
a few ways to
Magbaback ka,
migrate
tapos
your database to the cloud. There's a database migration service that you can use. Depending on the size of your database, there are different scenarios and different ways you can do it. Actually, for Azure, they have an database migration page wherein you can put your source and destination, and then it will tell you how to migrate it more efficiently. There's a few ways you can do it. You can do log shipping, you can do replication to the cloud, or for example, if you're talking about very big databases, for example, if you're talking about hyperscale, right? 50 terabytes, I don't want to restore that to the cloud, right? Because it's gonna take a long time. So what you can do is you can use Azure Import and Export, or use I think Azure Box, wherein they will give you an appliance where you can save your database, and then they can bring it to Azure, and they will restore it on the site on Azure. So there's a few ways you can bring your large database.
Yan,
Thank you, sir.
kahit saan din. Pwede ka. Ito, pwede.
So,
Kunti lang
Theo,
naman.
do you still have other slides to show?
No, that's all.
That's all. Okay. Thank you very much for sharing us your expertise. So our next speaker is Mohammed Asif. We'll be talking about managing data to the ledger using Azure Blockchain as a service. Blockchain.
Yeah, he's our Singapore blockchain expert at Singapore.
Blockchain expert.
Blockchain, ano din? Cryptocurrency.
So Asif specializes in Microsoft development, blockchain, mobile apps, and technology, cloud technologies. He works as a solution architect in ABN AMRO Bank. He's certified in Corda and Hyperledger development framework for blockchain, and he has successfully implemented solutions for trade finance and Quorum blockchain. So ano to, hindi ito yung mag-invest ka sa blockchain or something. It's more on of a technical side of the blockchain. Talagang dudugo yung ilong sa technical. De joke lang. Anyways, the floor is yours. Thank you.
Yes, sir. First question, are you Satoshi ba?